Hi everyone, I'd like to take a look at how to graph parabolas that are in vertex form, and hopefully this will be pretty quick today. So the first parabola we're going to look at is y equals parentheses x minus 2 close parentheses squared minus 5. And we're just going to look at how we would produce a graph of this. Before we do that, I want to talk a little bit about some of the features of the graph. So remember, this is a parabola, so our domain, just like always, is going to be all real numbers. That is always true because the graph exists forever as we look left and right. The range we're actually going to hold off on until we get a graph and until we talk about the vertex, because we're not exactly sure where this parabola's vertex is located. Next step, let's talk about the vertex. The vertex of this parabola is going to be at 2, -5. So let's talk about that quickly. When you see x minus 2 in parentheses, that means that our ordinary parent function, remember that parent function looks like this with a vertex at the origin, that function has been moved 2 units to the right. So the vertex is at 2, and then it's been moved 5 units down, so -5. So I'm going to plot that point right now. 2, -5 is the lowest point this parabola is going to reach. We know that this parabola opens up, because if we look in front of the parentheses, there is no value, which means our a value is equal to 1. With an a value of 1, it opens up and it's going to have an ordinary width. It's not going to be wider or narrower than normal. Let's talk about axis of symmetry. The axis of symmetry, remember, is that vertical line that splits the parabola in half. It's always simply x equals the x coordinate of the vertex, so x equals 2. I'm going to put that in the graph now as well. So here's my axis of symmetry. So we know that whatever points we plot on one side, we're also going to plot on the other. Other details that we would want to know about would maybe be the y-intercept. So the y-intercept is found when we let x be 0. So I'm going to do that. 0 minus 2 squared minus 5. That gets us -2 squared minus 5, or 4 minus 5, giving us -1. So we know that our y-intercept is at -1 right there. What's convenient about that is we actually get to also plot the equivalent point on the other side because of that axis of symmetry splitting the parabola in half. So we really get 2 points for the price of 1. So this one right here is the y-intercept, and this one over here is kind of like that sister point to the y-intercept. That's always really convenient to do. It's really useful if we have at least one other point. It's not super important, but it's kind of nice. So what we want to do is we want to just find a point that's close to the vertex. Well, the one that would really be close to the vertex would be something, say, along this line right here, along that line, x equals 1. So we're actually going to sub in x equals 1. I'm going to get rid of that line because it's not really an important part of our parabola. But if we sub in x equals 1 to the function, so 1 minus 2 squared minus 5, that's going to get us -1 squared minus 5, which gets us 1 minus 5, which gets us -4. So we know that at 1, -4, we have a point. And what's cool, we can use that sister point on the other side as well over there at 3, -4, because the parabola has symmetry. So now I'm going to connect each of those points with a nice smooth graph. We'll just do our best to make it decent looking here. There we go. And so now we have the parabola graph. So you're not going to do this by hand because that would be pretty challenging with the Chromebook and with the tech issues we're dealing with. But I am going to have you do this on some technology with Pearson Realize and Math Excel. So I just want you to see how we can generate those points on either side of the parabola. Do your best with it. If it doesn't work out perfectly, no big deal. The main thing I really want you to know is how to find the vertex and then how to basically know whether the parabola opens up or down from that. Okay, let's do one more. This time let's have a parabola that opens downward and is actually a little bit narrower than normal. So for this one, let's take a look at the parabola with equation y equals -2 parentheses x plus 3 squared plus 6. Okay, so I'm not going to go through all the properties again because my main point is for us to know where the vertex is and know whether this thing opens up or down. Okay, so first of all, I'm going to highlight that a value. Now we actually see a value in front of the parentheses. The a value is -2. Well, what that indicates for us then is that with an a value of -2, this thing opens down and it is narrower than normal. I know that's a little bit surprising because you might think a larger number would make it wider. The larger number actually makes it narrower because what it's producing is it's actually doing a vertical stretch. Okay, that of course doesn't matter right now really, other than that it's a way for us to check our answer. The most important thing here is where is the vertex? So the vertex is, now notice what we see. We see x plus 3. We're tempted to think that the x-coordinate would be +3. It's actually -3. The parabola has moved 3 units to the left, and the parabola has moved 6 units up. So -3, 6 is the point where we're going to plot for our vertex. So let's go there and plot the point. There's our vertex. While we're at it, we can also graph the axis of symmetry. That's the line that's going to cut that parabola in half. And that's the part that's going to allow us to, if we have a point on one side, we get for free a point on the other side. Okay. We might not be able to get the y-intercept. The y-intercept might be actually too far off the grid to plot, but let's go ahead and try it. So for a y-intercept, we're going to sub in 0 for x. And we're going to go -2 times 3 squared plus 6. -2 times 9 plus 6. Oh, yep, it's going to be off the screen. It's going to be down at -12. So, oh well, no big deal. The y-intercept's at -12, not a problem. What we would need to do then is we would need to try other points that are closer to the vertex. See, because like the y-intercept would be somewhere along, you know, the y-axis, and it's too far away from the vertex for us to really see. Okay, so we'll get rid of that. So what we can do is that we can plug in points that are nearby the vertex. So we can plug in -2 for x. I'm going to actually just do that on my calculator to save us a little bit of time. So if I plug in -2 for x, what I end up getting out is 4. So we end up seeing the point -2, 4. Well, -2, 4 lies there. And then we get for free that other point on the other side of the parabola. So that's convenient. And I'm going to do one more point. I'm going to plug in -1 into the function. And that gets me -2. So, oops, that made a little mistake there. -2 times -1 plus 3 squared plus 6. Yeah. So we're at the point -1, -2. So we'd be way down here. And again, for free, we get that other point on the other side. All right, let's now plot the parabola that actually goes through that. So I'll do that with a black pen. And here we have the parabola. So if we were in class and we had paper to do this with, we would do a bunch of these and we'd actually be real precise about it. I'm actually just going to have you do this online, and it'll be quite a bit easier. Okay, that is it for today. Thank you, guys.